Hi guys, you are welcome back to my channel. In our last class we talked about parallelogram method with some examples on that. So today we shall be looking at resolution of vectors. What do you mean by that? It simply means the process by which a particular vector is being resolved into its components. And when we say component of a vector, it means the effective vector in a given direction. For instance, the horizontal component of a vector is the effective value of that vector in the horizontal direction. So, component of a vector, there are two. We have the vertical component and the horizontal component. So, the process of obtaining this component is what we call resolution of vector. So, resolution of vector is a process by which a particular vector is being resolved into its component, the vertical component and the horizontal component. For instance, now, from this diagram, let's consider this diagram. Let's say we have two vectors. In this case, first, we have, let me use resultant first. Okay, let me resultant first. Let's say these are resultant. Okay, the effective value of this resultant along the vertical is the vertical component of that R, and we denote that by R subscript Y. Okay, the effective value of this resultant along the horizontal is R subscript X. So the angle the resultant makes to the horizontal component, let's call it theta. Alright, so let me draw a parallel line to RY. RY. Is in this topic, remember in the previous video, when you began resultant vector, to get the resultant, they will give you two vectors or two forces, right? You will not need the two forces to get the resultant. But in this case, it's like giving you the resultant and asking you to look for the two forces that bring about the resultant. Alright? So to get my RY now, I can apply trigonometric ratio. From the diagram, sine theta will give me, of course, where the side facing the angle is our opposite. The side facing the right angle is our hypotenuse. Then the third side is the adjacent. Okay? So if I want to get RY now, I apply sine theta. That's opposite to my hypotenuse. That is RY over R. From that place now, my RY becomes R sine theta when we multiply. So this is the vertical component of that vector. Vertical component. So if I want to get the value of RY, I use this. Similarly, cos theta will give me what? Cos theta will give me adjacent, that's Rx, over hypotenuse, which is R. So from that place now, my Rx equals R cos theta. So this is the horizontal component. So to get the horizontal component, you apply this formula. Remember what I said? That in this case, they will give you the resultant. Then ask you to look for the two vectors that will want the resultant. If you want to get the vertical component of that vector, it is R sine theta. So R can be any vector, can be force, can be velocity, can be any vector. Then to get the resultant, it is R cos theta. Let me give you an example. Example 1. Let's say an aircraft travels at 250 kilometers per hour in the direction 60 degrees east of north. That's something as north 60 degrees east, okay? Determine its velocity in the northerly and easterly direction. Easterly direction. That is in the north and east direction. Solution now. So the aircraft travels at 250 km per hour. Okay? So let's say the aircraft starts from here. Let's say this is the starting point. Okay? Then travels north 60 degrees east. In that direction, north. This is north, this is east. North 60 degrees east. So 60, you start from north. You start counting. So it will be more than half. So it will be very close to the east. Draw it like this. Okay? So it travels at 250 km per hour. So from here to here is 60 degrees. What will be left here? 30. Remember, from here to here is 90. So 30 degrees. So the question now says we should determine its effective velocity in the northerly direction. Now that is north. Okay? We have determined it in the north. So that north now corresponds to the vertical component. North to the vertical component. So to get that, I'm going to use, so number one now, effective velocity in the northerly direction is given by, now in this case, our R is V, is velocity. So velocity is a vector quantity. So our R becomes V. So we have Vy equals V sine theta. So don't forget that the knot they mentioned here correspond to the vertical. This is our knot here. So it's belongs to the vertical component. Okay? To the vertical component. So we have our V is 250 sine. What's our theta? So no, it's not 60. So that is one of the trap in this question. Not the 60 you are given in the question. Okay? Why is it so? Remember when I derived, we are using this formula. When I was deriving this formula, the theta is between the resultant and between the resultant and the horizontal. Right? So the angle you will use also must be between the resultant. In this case now, V is your resultant. So the knee is horizontal. And the angle here is 30. Do you get that now? It's not the 60 you are given because we are going to use. This is also jam question. So for those of you doing jam, take note of this. So when it has to do with resolution of vector or finding or resolving a vector into its component, the vertical component and the resultant, your angle must always be between the resultant and the horizontal. Because the original formula we have, the R1 and RS, the angle there, theta there is between the resultant and the horizontal. Please take note of that. We will see using theta in our next subheading. So the angle there is 30. And that will give us 250. Sine 30 is what? Or let me press everything. 250 sine 30 should be giving you 125. 125 unit is kilometer per hour. So that is the effective velocity in the northerly direction. Then the second one, effective velocity in the easterly direction. In the easterly direction is given by, so that is east now. So that's east, this is our east. That east corresponds to the what? Horizontal component. That's Rx. So invariably in precision of vector, you'll be given the resultant. Then you'll be asked to look for the two factors that bring about the resultant. It's like opposite of the way of getting the resultant factor. Okay? So we have Vx equals V cos theta. So our V is 250, the theta is 230. Because when I got this place, I didn't change the angle. So it's 230, not 60. Take note of this place. So 250 plus 30 will give us what? 216.5. After that 5? 0, okay. Kilometer per hour. Let me just do one more example and that will be all for today's video. Okay? Another example. Example 2. Let's say we are given this. A nail on a vertical wall. On a vertical wall is to be removed with the help of a cord attached to its head. If the cord makes an angle of 60 degrees with the horizontal and the force the cord exerts on the nail is 50 Newton. Determine Roman numeral 1 the effective force that tends to pull the nail out of the wall. Roman numeral 2 the effective force that tends to bend the nail. Okay? It's another question. Alright. Let's say this is the wall. This is the vertical wall. Okay, this is the wall. They said a nail is attached to that wall. Let's say this is the nail here. Okay? Let's say this is the nail. So they said that nail is to be removed with the help of a cord attached to its head. So they attached a cord. A cord to the end of that nail. And they said the cord makes an angle of 60 degrees. It means that the nail is not vertical like this. They said it's 60 with horizontal. These are horizontal. Okay? So the cord makes an angle of 60 degrees with the horizontal. So that 60 is an acute angle. So let's say these are 60. This is 60 now, acute angle. Straight down like this is 90. And that is the vertical component. Or the vertical direction. So these are resultant. And they said the force, the force, no, not the force, the cord. Let me put it here. The force, the cord, exert on the nail is 50 Newton. So the force is 50 Newton. Okay? They now said, determine the effective force that tends to pull the nail out of the wall. You have a wall like this. You attach a nail is attached to that wall. Then on the end of that nail, there's a rope, a cord. If you want to pull the nail out of the wall using the rope, how will you pull it? You will pull it towards yourself, right? You pull it like this, and that is horizontal. Okay? So the effective force that tends to pull the nail out of the wall is the horizontal force. Alright? So for the horizontal force now, for the first one, effective force that tends to pull the nail out of the wall out of the wall is given by Fy equals F sine theta. F sine theta. Okay? Now our force is 50. What about our theta? The theta is 60 in this case. Now it will be 30. Why? The 60 is with the horizontal. The previous one we did, the 60 was with the vertical. So we have to bring back to the horizontal. That's 30. But in this case, the 60 is already with the horizontal. Remember our formula, the theta is with the horizontal. So we have it here with the horizontal. So it will be 30. It's that same 60 we are given in the question that we are using. Alright? So we have 60. So 50 sine 60 will give us what? 50 sine 60. 43.30 Newton. That is the effective force that tends to pull the nail out of the wall. And the second one says effective force. Effective force that tends to bend the nail. Effective force that tends to bend the nail is given by. So for you to bend the nail, if the cord is like this, you pull it down, it will bend. But if you pull it straight like this, that's horizontal. But if you pull it, oh sorry, you made a mistake. It should be force. Effective force that tends to pull the nail out of the wall is horizontal. Okay? And horizontal is cos. Sorry, this should be cos now. I mean, once you calculate that again, this should be cos. So 50 cos 60 will give us 25, right? Now with 25 Newton, sorry. Effective force that tends to pull the nail out of the wall. This is the nail. If you pull it like this, horizontally, you are trying to pull it out of the wall. But if you pull it down, that is vertical. So it will bend the nail. You pull it out, it will bend it. Okay? So effective force that tends to bend the nail is the vertical component. And that is Fy equals F sine theta. But the one that tends to pull it out of the wall is the horizontal one. And that will give us 50 sine 60. And that is 43 points. What do you call that? 43.30. So this is the effective force that tends to bend the nail. The one that tends to pull the nail out of the wall is the horizontal one. Alright? So next class, we will look at result of more than two factors. But here, just take note of this. If for a result of factor, the angle must be with the horizontal. Take note of that. Okay? And for the vertical component, we use sine. For the horizontal component, we use cos. And the angle must be with the horizontal. Thank you for watching. See you in my next video.